This video focuses on delta load and how we can use the knowledge we've gained from earlier foundation fundamentals of electrical circuit videos and lessons to analyze a circuit that is at delta load. Just a refresher, a delta load would be load that is connected in this way. So you would have of course we're still talking about balanced loads, so you would have three loads connected as such on the three phases, and you may call this one A, B, and C, and you will have transmission lines coming in feeding each one of these loads. Now, we've done a lot of analysis. We've shown how we can use a single phase, something like this, when we have a Y source, Y load connection through a transmission line, and how we could just use one single phase to do the analysis and figure everything out. So we have a choice of doing similar set of analysis and similar set of equations for a delta connected load, but life is a lot easier than that, and we don't necessarily have to do that because we can literally convert this, basically take this A and B and C and replace it with a Y connection. Basically what we're doing, we're converting our delta load into a Y load. And it would behave as if the delta load was there. And what that does, it allows us to take advantage of all the Y load activities and analysis that we've done earlier and apply it to this load, which is a delta load. And so the only thing we have to remember is that when you convert between a delta and a Y, the ratios are Z delta is 3 to ZY. So for example, when we're going to delta to the Y connection, just take the whatever Z delta is divided by 3, and that becomes the load. After you've done that, then you can simply use the analysis that we learned in earlier videos on Y to Y connections and get that done. And then you can find all the phase voltages and currents. Now, the important thing to remember here is kind of remember what the phase voltages and phase currents are. In the case of a delta load, phase voltage and line voltage are the same thing, So basically this is a line because that's a line, and this is a line, therefore this is a line voltage VAB. That this is also a phase, so this is also a phase voltage. So they are the same thing, and this is fine. If you remember, this is kind of a little bit opposite of what the Y connected loads had to do. Now, the other thing to remember at this point is that unlike the Y connected load, this is the line current, but this is the phase current, and they are not equal to each other in a sense. So if I want to do the calculation, what I have to do is first say, okay, let's say in each phase, first phase, the I is equal to I magnitude of phase angle 0, and this is a ABC or a positive one, so the BC is going to be minus 120 and CA is going to be plus 120. So IAB is always 0, that's a reference one, and we decide that. And of course the letter phi talks about the phase current. Now the question is how we're going to take that and convert it into a line current. So it's, if you look at it, if you take for example this node, you will find that this current is going to be equal to this current minus this current, or if you're basically applying Kirchhoff's current law to that. So if we do that, we'll find, for example, for this one, IAA is equal to I capital AB minus ICB, which is basically saying this current, or just what I said, this current is equal to this current minus this current. So we're going to apply the equation and do some trig, and we'll end up with this equation. So this is great, because now I can take my phase current, put it in here, shift it by 30 degrees and multiply it by square root of 3 and get my line current. So I'm going to go from my phase current to line current here. And you do the same thing for all the other ones. Here's a vector representation of the phase and line currents. And of course, if the phase sequence was negative, all it does, that 30 degree shifts from one direction to the other direction. This was kind of, in many ways, we can leverage our Y-to-Y connection to do the analysis of circuits. And then if you get a delta connection, just first thing you do, you go ahead and convert your delta to Y, and then you can go back and use all the stuff you learned from Y connection. Okay, and the only other thing you got to remember is that when you're in a delta connected load, the voltage, line voltage and a phase voltage are the same thing, but line current and phase current are not, and you find these equations, we use these equations to do the conversion between the two.